Okay, good morning everyone. This is Mr. Cele. Today we will be looking at the Newton's laws of motion. Besides saying the Newton's laws of motion, we have to think about some real life scenarios. Ukuthi ikuphi la khona esimbona khona Newton's Newton's laws of motion. So apply kuphi. Well, the late Sir Isaac Newton discovered these laws, mainly based with motion, that is a movement into a particular direction. He mentioned the factors considering the forces, the acceleration, and the mass of any particular object. Taking, for example, discovering Newton's first law of motion, kwamenza ukuthi wakwazi ukuthi understand ukuthi, for example, sihlala elokishini, we have itimela. So itimela it's a mode of transport esisebenzisa kakhulu. So if isitimela, assume sihamba 120 kilometers per hour, speed leso sesitimela. So if you decide ukwehla istaff njengoba bake benze komobeni nakuphi nakuphi, if you decide ukuthi wehla istaff esitimeleni sakho lo 120 kilometers per hour sekuzoba initial velocity yakho. Why? Akusiyo umlingo, that is the law of inertia, which is given ama details by Newton's first law of motion. So that is first law in passing. Now let us just simplify Newton's second law of motion. By Newton's second law of motion, it's a very unique law that has to deal with the relationship between the net force and the acceleration. Uthini yena Newton's second law of motion? Newton's second law of motion is suggesting ukuthi if the force is exerted on a particular object, that object will accelerate in the direction of that force. Not just any force, but the net force, the final force that an object will consider due to its motion into a particular direction. So having said that, since we know there's a relationship that is so important between the net force and the acceleration, so we have the relationships that will be given by graphs, the relationship that will be given by the objects. Remember, this is physics, this is paper one. We have to be strict about the quantities. Here we are talking about large objects, so we might as well, under any circumstances, understand physics, that is kilograms. My units, we mass, my kilograms. This is physics. We are working with large objects. So that is all. As for Newton's third law of motion, it is it's a funny way of saying if ungenzela okuhle, if ungenzela okuhle, nami kumele ngikwenzele okuhle back ngendlela efanayo. That is a funny way of saying that. If you give nawe kumele uthole something back in return ngendlela efanayo, but opposite, in opposite direction. That's what Newton's third law of motion is saying. Angazi ke kusuke sekwenzakalani for a particular scenario where we have someone ozogijima ayothi ngqu odongeni, udonga luzo exerta a force elinganayo naye nale force ayi exerta back odongeni. Kodwa manje yena uzolimala, udonga ngeke luze limala. That is Newton's third law of motion. Yona interest sinesuke sibhekile leyo Newton's third law of motion. As for law of universal, Newton's law of universal gravitation, sisuke sesibhekeke manje kwi-universe. Uma sithi universe, it's something that we are 90% sure and 10% unsure ukuthi ngempela it exists ngale yandlela. But the physics parts that we know ukuthi whenever you are in a gravitational field in the atmosphere, we have those gases, those nitrogens, those oxygen that are produced by trees and stuff, those CO2 that are produced by our emissions. We know ukuthi there they get to be reduced in terms of their concentration. Well, we are not too much care about that, but as we know, this is a gravitational field. What goes up must come down. Why? Earth is humbling any object that has a mass esuke siyiphonsa phezulu. U-earth is humbling you and u-earth is saying, no, let me help you, my kid, because my child, you have a mess, I will pull you down. But what I know, you will not pass the ground. So that's what u-earth is saying. U-earth is pulling you towards its center. That's why uma decide that uyiphonsa phezulu ebuilding, angeke uze udlule iground. Kodwa uzoshona kuphi? Uzoshona phansi, angeke wenze horizontal, angeke wenze vertical movement, because earth is humbling you each and every moment. So that is the real life scenarios uma sithi nje Newton's laws of motion. But into details, I'll just unpack our properties according to these laws. Mind you, for enrichment, Newton's laws do apply kwamanye ama scenarios. Uyawuthola kwamanye ama field kwa-maths, there is Newton's as far as Sir Isaac Newton is concerned. So as for starters, we are saying Newton's laws, the Newton's laws of motion. We have first, we have second, we have third, and then we have fourth according to our categories. So having that, I would like to say first, the first law. The first law is suggesting, according to Newton's, the first law is suggesting that an object will remain in its state of rest or motion at a constant velocity unless it is acted upon by unbalanced forces. So we have this whole of the definition, which is not that important, all of it, but we have the key terms, the key concepts that we have to make sure we understand. As also discussed the power first law. We have states of rest. We have motion, not just any motion, but the motion at a constant velocity, and then it is acted upon by unbalanced forces. During the day, olele ngesikhathi esirong ozumekile embhedeni thatha indisha amanzi umuthi qu, that person was at rest. The only movement ezokhozeka lapha izokhozeka if usumthele ngamanzi. Now amanzi will do what? It will exert an unbalanced force. That's why that person will no longer be angeke asaqhubeka nokulala ngesizathu sokuthini, ngesizathu sokuthi there was an unbalanced force that was introduced by means of amanzi. It's a force akuyona indlela yokuthi bakuhlukumeze. They are just doing Newton's first law of motion. What are the properties of Newton's first law of motion? The very pivotal property each and every time uma ngithi Newton's first law of motion, it's the one that is saying or suggesting that F net is equal to 0. The sum of all the forces is equal to 0. Why that is the case? This is the case because the acceleration is indeed 0. And why that is the case? That is the case because we have the motion at a constant velocity. If we are having an object that is moving at a constant velocity, the acceleration of that particular object is equal to 0. Without any confusion, if we're having an object that is initializing, that is v, velocity initial, at 2 meters per second, and still between any 2 points, that object is finalizing with the final velocity of 2 meters per second. This object is moving. It is not stationary. it is moving, it is in motion, but due to the equal change, due to the equal in final and initial velocity, the change here, if we are saying change in v, the change here will be equal to 0. There is no change in the velocity of an object. And if there is no change in the velocity of an object, this will assume that taken from the formula A is equal to change in v over change in t. And then doing the substitution of that 0 here will weigh us down into a change in v, which is 0 over a change in time. So this change in time will die, of course, and we are going to be left with the acceleration of 0. It's 0 and not 0 meters per second squared. It should be 0. Yeah, so that is one of the cases that where la khona is apply khona Newton's first law of motion. There is enye indlela yokusho ukuthi there was L there. It comes from the law. It is the law of inertia. The law of inertia. So we are saying Newton's first law of motion, aka also known as the law of inertia. Inertia is saying lento ebengisho ekuqaleni yesitimela. If isitimela sihamba 120 kilometers per hour, wehla istaff, now initial velocity yakho izoba 120 kilometers per hour. Akekho umuntu okuthakathayo njengoba kwenzeka leyo into leyo ukuthi uma wehla isilandela akekho umuntu okushaya ngezulu ukuthi ulandele izitimela wena uma wehla istaff. No, this is the law of inertia. This is science. This is according to Newton's first law of motion. Uthini inertia? Inertia is suggesting that is known by definition as the tendency of an object to do what? To resist a change in its uniform motion. So that is inertia. So as we all understand that inertia is the specimen. It is one of the ingredients that's made up Newton's first law of motion. Having all of this, there are other details that applies the Newton's first law of motion. Without further ado, I will just give an interpretation of just any scenario. Any scenario will be a case where we are having maybe, let me take for starters, let me say we have a glass filled with water, half filled with water, and then you decide to have your paper there. And then maybe you can just put 50 cents. I don't know if there's anyone in these days who owns, who tend to own 50 cent, no more 1 rand. Maybe you can put 5 rand there. And then now let us have A. Let us say A. We have a sharp pull, and then on B we have what we call the gentle pull. So we are having those two particular scenarios. And when we are doing the sharp pull, now this is what's going to happen. When we are doing the sharp pull, this object here with the mass will remain according to inertia. It will resist a change in motion that is produced by that paper. Because what you are doing there, you are doing a sharp pull. We are just grabbing that paper so that lawyer 5 rand lawyer uzosala ngenxa leya mass usuzokwenza kanjani nona usuzodescend and then fall down inside the glass filled with water. Why that is the case, we are performing the sharp pull. So if we are doing the sharp pull, these five rands there will resist a change in motion that is produced by that paper. Now seeing abantu abasebenza e-restaurant asebene experience kakhulu, bafike bandlala itafula kahle bahlele and then that will come as a surprise ukuthi let me perform Newton's first law of motion. It is risky, I must say, but they are doing science after all, so we might as well talk about things like hypotheses. There are 25% chances of meeting the hypothesis, so we must not get away from that fact. So you'll see isikhathi esiningi mhlawumbe into azoyenza to surprise those individuals abasuke bekwi-date couple siphuma kwi-Valentine manje, so can talk about those things. So mhlawumbe uzobathusa nje kancane, it comes as a surprise, and then athi sharp pull leya ndwangu leya abasuke bebeke kuyona leya setup yabo. So if enza i-sharp pull wonke ama-objects azosala. Why this is the case? They will resist a change in the uniform motion due to that inertia. But when you are performing the gentle pull laphaya kuleya case, well, donsa kahle iphepha lizohamba nayo yonke i-mass. Now you are going to take that as a system. You are having an additional masses, the mass from the coin and then the mass that is added from the paper. So you have this, you are having a system. So please do think about that. Another cases you'll find out there will be, because science is colorful. Science is okay. I get my hands dirty doing science, so so I might as well have scenario here. It is, so I have theta. Okay, this is P, this is Q. Okay. Okay, let me give the ropes the names. Let me say this is P. Oh, yeah. Oh. Okay. Now let us try and demonstrate again Newton's first law of motion, aka inertia, the law of inertia. But let us try sibuye ngendlela manje ehlukile. Ethanda ukuba more details. Ethanda ukuba nama details amaningi as compared to leya yokuqala. So let me just say here we have scenario 1. Okay. Now let me say you have, for example, this is scenario 1, and then here let me just say you have scenario number 2. So having that now, let me say we have two objects, that is M1, and then we have M2 there. That is okay. The case, maybe say we have the force of 20 Newton that is pulling those two objects in the same direction. Okay. So now let me say at this point
we have the same object that is pulling two objects.
We have the same force that is pulling two objects. Okay, we have the same force which of 20 Newtons that is pulling two objects, that is M1 and M2. So what we have to consider is the fact that but the acceleration is the same because they are being pulled by the same force, and also the tension is the same between them. Why? It's because again there's only one rope that was used to pull them. So that is the case. So I'm not there much because masengithi acceleration, sengithi net force, sengikhuluma indaba kaNewton's first law. Mina ngizeki, I mean indaba kaNewton's second law. Excuse me on that part. La we are here to discover indaba kaNewton's first law, which is the law of inertia. So I'll just put 2 points. We have point P there, and then let me say here we have a point Q. This is just a point anywhere laphayana with-strain. So now, interest yami sekuthenini according to inertia, what will happen? What will happen with motion yalo M1 if this point here tend to do what? Tend to break. If that point breaks, that's where my interest is. So now, if P ezoqashuka seemingly, what we are going to have there, we are going to have two sets of accelerations, and that is an unusual case. The one set will come with sorry about that, with inertia. It will come with,
The second one will come with inertia.
okay, it will come with inertia. Why it is inertia? It will, I will just show with the arrows. Its direction is othatwa M1. Inertia ka M1, ngoba u M1 currently ube move towards I direction yakwabani yakwa east. Inertia izoqala ithi east ka M1. So that will be according to inertia. That is the first part of acceleration. This is the acceleration due to inertia. And then, kuzoba khona acceleration that is acceleration due to tension. The acceleration due to tension will act in the opposite direction. So now, what we have to understand is the fact that this acceleration here, let me say the acceleration produced by I for inertia, and then here is its acceleration produced by tension. So this acceleration here will be greater than the acceleration that will be produced by tension. Why this is the case? This is the acceleration of getting there with that 20 newtons. And this is the acceleration of slowing down to say, hey, mina, I was kicked off from that motion. Ngihluthiwe mina ilungelo lami lokuthi ngihambe naloya 20 newtons. So I am going to respect ukuthi string masiqephuka singisa ngakuphi. So I will respect its tension. But inertia is suggesting ukuthi I was moving towards the east with that tension or with that force as a system of 20 newtons. So please be aware of ama cases anjaya, especially they use ama terms afana nokuthi ama terms anormal ati the string breaks. That will occurs